Now this is an offline session for you. Now I would like to tell you about how to draw the sequence networks. For an example, if they have given a certain figure as like this, the figure is like this. It consisting of a generator, it consists of a bus, and then it consists of a transmission line. This side one more transformer and a bus and a motor. This is a generator, this is a motor, this both are synchronous generators, and this is star with reactance grounding. This is delta star grounding transformer. This is star grounding delta transformer, and this is normal star without any neutral. So here there are certain markings. Let us say this is M, this is say N, this is say U, this is say after transformer, this is say V. Suppose if they will give the circuit like this and they will ask you to draw the three networks. One is positive sequence network, other one is negative sequence network, and other one is zero sequence network. As you know already about these sequence networks, just I am drawing for you directly because in the last class you have studied how to draw the positive sequence network for the alternator, transformer and the transmission line. The same we are applying here. Firstly, let us draw the positive sequence network. First one is the positive sequence network. Firstly, we need to draw a reference bus. This is the reference bus. So obviously the generator has to be represented with an it has some internal EMF, EG, and it is having some reactance. So the generator reactance. After this point is M. This point it has having a transformer. The transformer is also having its internal impedance or leakage reactance. So I am representing the transformer here. This is N. Here there is no point of neutrals here or delta star connections. Those all the points will come into the role only in case of zero sequence network. For the transmission line also it has some reactance. So the transmission line reactance, it is taken as U. After again the transformer reactance I have taken, after which one more motor is there, synchronous motor. The same principle it is running out. So this is V. This is the positive sequence network of a system. Now if you want to draw the negative sequence network, this is as simple as that. If you remove this and this, it will become negative sequence network. So the negative sequence network will be the generator reactance and the transformer reactance. This point is M, this point is N, and the transmission line reactance, this is U, and another transformer reactance, this is V, and then the motor reactance. Now the final point is about the zero sequence. This is the very important. Most people used to most of you actually used to confuse about the zero sequence reactance while delta and star. So in order to make that crystal clear, I'll draw a simple circuit. See the carefully. Let me draw in black since it is zero sequence. Firstly, draw the reference bus as usual. After drawing the reference bus, take from this middle or this middle. If you take from this and this end, you will get confused. So take from the middle. Here the transmission line is both sides connected to star grounding. Grounding in the sense it is connected to reference bus. So the transmission line reactance along with the transformer this is N, this is transmission line U, and this is another transmission line V. So this is connected. Okay, now what's happening, the motor is star grounding but it is delta connected. So the motor itself have its some reactance Zn, 3Zn, and its own reactance Z0. So this is M. This is delta connected, so there is no circuit that connection between this and this, so delta connection is open. Similar, there is no star connected here as well, so hence if there is no star connected, it will consist of only Zn, or I can say simply Z0. This is V, this point is V. This is not connected to here because this is delta. This is also not connected to reference bus because there is no connection here. This is how you need to draw. This is not connected to reference bus, please understand. This is how you need to draw the circuit. Okay.